for you guys, and I forgot to start recording, so I'm so sorry about that. Okay, so let's go over another example for you guys. Example number 2, they're asking us to find the linear equation for this line. So again, we're going to use the information that m equals y2 minus y1 over x2 minus x1. And I'm going to pull 2 points from my graph here. So I see a point right here, and I see a point right here. So those points are negative 1, 4, and 4, 1. And I'm again going to label them as x1, y1, x2, y2, because it makes it a little bit easier for me when I get started. So I'm going to determine my slope. So m equals 1 minus 4 over 4 minus negative 1. And I'm going to go ahead and solve that. So 1 minus 4 is negative 3. And 4 minus negative 1 is 5. Remember, I'm adding those. It's technically 4 plus 1. So my slope is negative 3 over 5. So I'm going to start to write my equation in y-intercept form. So I'm sorry, slope-intercept form. So y equals negative 3/5 x. And if I come over here and I look to see where my line is crossing that y-axis, it's crossing between positive 3 and positive 4. So that means that my y-intercept should be positive. So we're going to let's use this point right here to figure out what our y-intercept is. So we're going to use that slope-intercept form, and we're going to plug in our numbers to determine what our y-intercept actually is. So we're going to use the y value 4. So we're going to say 4 equals negative 3/5 multiplied by negative 1 plus b. And we're solving for that value of b. So the first thing that I'm going to do is multiply negative 3/5 by negative 1. And since I know that a negative times a negative is a positive, I'm just going to carry my equation down here so that 4 equals 3/5 plus b. And now, in order to get b all by itself, since that 3/5 is positive, I need to subtract 3/5 from both sides of my equation. So minus 3/5. So this is going to tell me exactly what b equals. So this equals 0. So now I have 4 over 1 minus 3 over 5. And I need to get a common denominator, so I'm going to multiply both the top and bottom of my fraction by 5. So now I have 20 over 5 minus 3 over 5. So that gives me 17 over 5. And I'm not going to change that in any way. I'm going to leave it just as it is. But I am curious, 17 divided by 5 is what? Because I need to know, is that number between 3 and 4? So 17 divided by 5 is 3.4. So that means that that number or that fraction is right between 3 and 4. And I'm content saying that my y-intercept is 17 over 5. So I'm going to fill in the rest of my equation, plus 17 over 5. That's my y-intercept. So my final equation in slope-intercept form for this line is y equals negative 3/5 x plus 17 over 5. So this is telling me that from each of these points on my graph, I'm going to move down 3 units and to the right 5 units. And my graph is going to cross my y-axis at 17 over 5. So I'm good with that information. Now, I just want to review with you guys really quickly. From yesterday, we talked about converting slope-intercept form into standard form. So we're going to do that with this equation right here, right now. So I'm going to erase a little bit of this just so I have a little bit more room. I'm going to leave that there. Okay, so remember that when we were converting into standard form, remember that standard form is ax plus by equals c. Remember that a, b, and c are integers, so they cannot be fractions, and a cannot be a negative number. So you can already tell that we've got a couple of issues in terms of our slope-intercept form and transforming it into standard form. So remember, the first thing that I did yesterday was rewrite my equation. So I've got y equals negative 3/5 x plus 17 over 5. And this equation is really fun because both of these fractions have 5 in their denominator. So very easily, I'm going to multiply my entire equation by 5 so that I get rid of those 5's in my denominator. So I'm left with, remember I'm multiplying that 5 by y, so I'm left with 5y equals negative 3x plus 17. And I always like when I have a negative on the right side of my equation because I can easily add 3x to both sides of my equation. And now my equation is in standard form. 3x plus 5y equals 17. 3, 5, and 17 are integers, and a is not negative. So I am happy with that standard form of my equation. Now, you guys will not have to do this for all of these problems. I just wanted to give you a reminder of how we do that. So we're going to take a look at another graph of a line of a linear equation where we need to figure out what the linear equation of that line is. We're going to do the same thing that we've been doing in these past couple of examples. So here we're looking at another graph of a line, and notice this time we can't tell where our line is crossing the y-axis because our y-axis is way over here and we can't actually see it. So we have absolutely no idea where our line is crossing the y-axis this time. That's okay though. We don't need to know that information. We can figure it out. So we're going to figure out, or we're going to take 2 points from our graph. So I see 2 points right there. And we're going to use that information to figure out what our slope is. So remember again, m equals y2 minus y1 over x2 minus x1. So my first point is, and this is going up by 1 unit each. So my first point is 12, 2, because I'm at 12 on the x-axis, and I move up 2 units to get to that point. So I'm at 12, 2. And then my next point is at 13, 1, 2, 3, 4, 5, 6, 7. 13, 7. And I'm going to label these points to make it easier for me. So I've got x1, y1, x2, y2. And so now I'm going to subtract 7 minus 2 over 13 minus 12. So when I do that, I end up with 5 over 1. And instead of writing the fraction 5 over 1, we can just write that as 5. So our slope is 5. So we're going to start our equation writing out y equals 5x. And since we really have no idea where our line is crossing our y-axis, we're not going to put a plus or minus because we really don't know if it's positive or negative. We can kind of assume that it'll be negative because we're seeing that it is going to cross the y-axis way down here if we were to continue our line out. So I will add a negative or a subtraction sign to this because I know that my y-intercept is going to be negative. So now we need to solve for our y-intercept. So we're still going to use the form y equals mx plus b as we're solving for b. So I'm going to use this, and it doesn't matter which of these points you use, but I like to use the first one. So I have 2 equals 5, and I'm plugging that x value in for x. So 5 times 12 plus b. So when I multiply 5 times 12, I get 60. So 2 equals 60 plus b. And because that 60 is positive, I'm going to do the opposite of addition and subtract 60 from both sides of my equation. And 2 minus 60 is negative 58. So that means that my y-intercept is negative 58. So it crosses the y-axis way down on my y-axis. So my equation is y equals 5x minus 58. That y-intercept is negative 58. So now I have the slope-intercept form of my equation here. Now, I want to show you guys, this one's a little bit easier to transform our slope-intercept form into standard form. So we're going to do that right now. And I apologize for my dog. Okay, so we have the equation in the form y equals 5x minus 58. Remember, we're trying to get it into the form ax plus by equals c. So the first thing that I'm going to do here is I am going to subtract 5x from both sides of my equation to get that 5x and the y on the same side. So I'm left with negative 5x plus y equals negative 58. But remember, my a value cannot be negative. So I'm going to multiply my entire equation by negative 1 so that I get rid of that negative in front of the 5. So I'm going to multiply that -1 by the -58. I'm going to multiply it by the positive y, and I'm going to multiply it by the -5x. And a negative times a negative is a positive. So I'm left with 5x. A negative times a positive is a negative. So minus y equals 58. And that is the standard form of my equation. So there's my standard form there. All of these, I guess it doesn't matter if you give me slope intercept form or standard form for all of these. But we were solving it in putting it into slope intercept form because it made it a little bit easier for us. So that would be the way that we would find standard form for that equation. Let's look at one that looks a little bit different before we go over all of the concepts that we've learned so far about linear equations and the graph of linear equations. So this one is a little bit different. And the reason that this one is different is because we can say right away that our line is crossing our y-axis at 0, 0. So our y-intercept in this case is 0. So our y-intercept is 0. So that's good information for us. It means we don't need to find our y-intercept. We already have it. But we are going to still use, even though we could see how many units up and over to the right or left we need to move, we're still going to use 2 points on our graph and determine the slope that way. So I'm going to choose this point right here and this point right here. So I have -3, -1, and I have 3, +1. And I have x1, y1, x2, y2. So when I write out my equation, I've got 1 minus -1 over 3 minus -3. So that means I actually have 1 plus 1 and 3 plus 3, because remember when we're subtracting a negative, it's technically addition. So I have 2 over 6, and I can simplify 2/6 to 1/3. So that means that when I write my equation out in slope-intercept form, I very simply have y equals 1/3 x plus 0, but we don't need to include that 0 in there. It's just known. So y equals 1/3 x is my equation in slope-intercept form for this line. So there's my linear equation for that line. So this one was a little bit easier to do in terms of finding the y-intercept because it was given for us. It was easier to say that our line was crossing at 0, 0 along our y-axis than it has been in the past couple of examples. So now that hopefully you guys understand that, we're going to go through a couple of concepts that we have not necessarily talked about, but we've gone through and done. So in my next slide, it's going to be blank. And I'm asking, what do we know about graphs of linear equations? So there are actually 6 things that we know about graphs of linear equations. And we have done or gone through and done almost all of these 6 things. So at the end of our lesson today, we're going to go over those last couple things that we have not yet. So the first thing that we know is we can use 2 points on a line to find the slope. So I'm going to write that down. We can use 2 points on a line to find slope. And we were doing that earlier today in our lesson. And remember, we do that because m equals y2 minus y1 over x2 minus x1. That is the equation that we use for that. We also understand, so for number 2, I'll write it in black again, we also understand that the slope-intercept form of a line is y equals mx plus b. So the slope-intercept form of a line is y equals mx plus b. And we have been using that in our examples. We also need to understand what the slope-intercept form is telling us. So we're going to add that too. So for slope-intercept form, so y equals mx plus b, remember that slope-intercept form tells us 2 things. It tells us the y-intercept. So b is our y-intercept. And it also tells us our slope. So I'm going to write that up here. Slope. M is our slope. So that number in front of x is always our slope. So far we have used all three of those things. The fourth concept in terms of graphs of linear equations is we need 2 points on a line or 1 point and the slope to write the equation of a line. And we actually just talked about how we do this, and we're going to look in more detail about how we do this in the next exercises. So we need 2 points on a line or 1 point on a line and the slope to write the equation of the line, and the slope to write the equation of a line. And if you are unable to copy all of this down, remember I will be posting it after our lesson is over. So we just talked about using 2 points on a line to write the equation of a line. And we also just talked about using 1 point on a line and the slope in order to write the equation of the line. And remember, when we use that 1 point on a line and the slope, that is allowing us to find that y-intercept. So I'm actually going to underline that here. So 1 point on a line and the slope allows us to find that y-intercept. So I'll write that there for you. Okay, so remember I said we have 6 of these. So number 5 is when you multiply the slope by the denominator, x2 minus x1, you get, so this one's a little bit confusing. So when you multiply, and we're going to use this as well, when you multiply the slope by the denominator, x1 or x2 minus x1, you get m multiplied by x2 minus x1 equals y2 minus y1. And this is going to come in handy for us today as well. And we actually have a name for this equation. We call it the point slope form. So this is called point slope form. We're using a point and we have the slope and we're creating an equation. So we're using that in terms of number 6, and I'm going to write it really small down here, number 6. So if you have a point, xy, then the equation of that line is written as the slope times x minus x1 equals y minus y1. So I'm going to write that out. If you have a point, xy, then the equation, I'm just going to write EQU, then the equation is written as m times x minus x1 equals y minus y1. And we're going to take a look at that in more detail in our next couple of examples. So some of this might look confusing for you guys. I don't want it to. I'm just introducing to you a couple of more concepts before we look at our exercises. So we're going to use all of these concepts today as we are trying to determine the equation for a line. So I'm going to move forward. If you need me to come back to this slide at the end of our presentation, I am more than happy to. So I'm going to move forward and we're going to start looking at exercises. There are just a couple of exercises for us to go through. I won't keep you past 11:20. So it is asking us to write the equation for the line shown in this figure. So I'm going to do that again by using 2 points on my line to calculate my slope. So here's 1 point and here's another point. So my first point is 2, negative 2. And my second point is 5, negative 1. And I'm going to write out whether these are x1, y1, or x2, y2. And I'm going to find the slope of this line. So I have negative 1 minus negative 2 over 5 minus 2. And really, so what I really have here is did I do that wrong? 5, negative 1. That's right. And 2, negative 2. Nope, I did that right. Okay, so negative 1 minus negative 2. I did it wrong in my notes for some reason. That's all right. So I've got negative 1 minus negative 2. And for me, that equals 1. And then I have 5 minus 2, which is 3. So my slope is 1/3. That's great information. I can even check my slope because from this point right here, which is 2, -2, I can move up 1 unit and to the right 3 units to get to my point 5, -1. So I can actually confirm that my slope is 1/3 in this problem. So I'm going to write over here the start of my equation in slope-intercept form. So y equals 1/3 x. Okay, now we're going to use a point on our line and the slope in order to calculate the y-intercept. Because right now we don't know, well, we do know that where that line is crossing the y-axis. It's between -2 and -3. So I know that my y-intercept is going to be negative. So I'm going to add a negative there. So I'm going to use that slope-intercept form. So remember y equals mx plus b in order to figure out what my slope or my y-intercept actually is. So I'm going to plug into my equation, y is -2 in this first point. So -2 equals, my slope is 1/3. I'm going to multiply my slope by 2 because I'm using that y value of 2. And then I'm going to solve my equation for b. So the first thing that I'm going to actually do is multiply 2 by 1/3. So I'm left with -2 equals 2/3 plus b. And now because that 2/3 is positive, I'm going to subtract 2/3 from both sides of my equation. So minus 2/3. So now I have -2 over 1 minus 2/3. So I need to multiply the top and bottom of my fraction by 3. So I've got -6 over 3 minus 2/3. And remember, when we have a negative number and we subtract a number from that, it gets to be a larger negative number. So now I have -8 over 3 as my y-intercept. So that, I'm going to add that to my equation up here. So minus 8/3, that is my y-intercept. So I want to see if that makes sense. So if I divide 8 by 3, that gives me 2.666 repeating, so about 2.7. And so I ask myself, negative, is -2.7 between -2 and -3? Yes, it is. So it makes sense to say that my y-intercept is -8/3. So that is the equation that for my line that I did not know before. And we used that slope, and we also used 1 point on the line and the slope in order to figure out what the y-intercept is. So we're going to look at another example where we do the same thing. So I think I have 2 more examples for you guys. All right, so let's look at this line right here. Remember, we're going to use 2 points on this line in order to figure out what this y-intercept is. Well, we're going to use those 2 points to calculate the slope. So here are our 2 points. So 1 point on my line is -3, 7. -3, 7. And then the other point on my line is 2, 8. So here's 2, 8. Okay, now I'm going to label those x1, y1, x2, y2, and I'm going to figure out my slope. So my slope is 8 minus 7 over 2 minus -3. So that means I have 1 over, remember when we had that subtracting a negative, we're actually adding. So 2 minus -3 is 5. So my slope is 1/5. So y equals 1/5 x. Now I can see that my y-intercept is going to be, I am going to figure out what my y-intercept actually is by using a point on my graph. So I'm going to use this first point again. So I'm using that slope-intercept form. So 7 equals, I'm using that point from my line, 7 equals 1/5 multiplied by -3 plus b, and I'm solving for that b. So first I'm going to multiply 1/5 by -3. So I have 7 equals -3/5 plus b. And so I can easily add 3/5 to both sides of my equation. So that's 0 right there, plus 3/5 over here. It's supposed to be a plus. So I've got 7 over 1 plus 3 over 5. And I'm going to multiply the top and bottom of my fraction over here, if I can write, by 5 over 5. So I'm left with 35 over 5 plus 3 over 5. So I've got 38 over 5 as my y-intercept. So that equals b. And I'm not going to simplify that. I can't simplify that. I could turn it into a mixed number, but I'm not going to. So 38 divided by 5, I just want to check, is 7.6. 7.6. So I'm asking myself, is 7.6 between 7 and 8? Yes, it is. So it makes sense to say that my y-intercept is 38 over 5. So the equation for this line is y equals 1/5 x plus 38 over 5. So you guys are going to see a problem or two in your homework. I actually cut your homework pretty short for today. That looks just like this. And then you're also going to see the next two problems in your homework. So I'm going to go through those really quickly. And in these problems, we're doing the same thing. We're still finding the slope. We're still finding the y-intercept, but we're not given a graph to do those things. We're given our points instead of finding the points on the line. So right away, the first thing that I'm going to do is I'm going to make these x1, y1, x2, y2. So I'm going to figure out my slope. So I've got 3 minus 5 over 2 minus negative 4. And 3 minus 5 is negative 2. And 2 minus negative 4 is actually 2 plus 4, so that's 6. So my slope is, I'm going to simplify this to negative 1/3. So there's my slope for me. It's y equals negative 1/3 x. And now I'm going to use one of my points that they've given us and my slope to figure out what my y-intercept is. So I'm going to use this first point here. So I've got 5 equals negative 1/3 multiplied by negative 4 plus b, and I'm solving for that b. So I'm going to multiply negative 1/3 by negative 4. So I've got 4/3 plus b, and I'm going to subtract 4/3 from both sides of my equation, minus 4/3. So I've got 5 over 1 over here, minus 4 over 3. So I'm going to multiply the top and bottom of my fraction by 3. So I've got 15 over 3 minus 4 over 3. So I end up with 11/3 as my y-intercept. So I can say that the equation of this line is y equals negative 1/3 x plus 11/3. That's the slope-intercept form of this line. I just used the information that they gave me to figure out that equation. So we're going to go through one more example with you guys, actually two more. And the last one is really important. So I'm going to try to do this as fast as I can so I don't run over my time. Whoops, I guess I didn't add those in there. Okay. So let me see if I